and painless as possible. You're welcome. All right, so here's what a growth or decay equation looks like. Okay. The A, the B, the H, and the K are variables that we will plug in values for. While we are here, A still does the same thing. A determines the direction up or down, and it also shrinks or stretches. That's what A is always going to do, always and forever, when it's in front of a function. B is what determines if it's growth or decay. All right, B is always positive. If it's negative in front, that means A is negative, not B. Okay? So if B is less than 1, it indicates to us that it is a decay function. But if it's greater than 1, it is growth. And I'll show you what these look like and what this means. Like if I have y equals negative 1/2 to the x, in this case, A is negative 1. B is 1/2, which would tell me it's growth. I'm in decay. Yeah. I was sitting here thinking about showing you a growth graph, and I said growth and then decay. It's decay, it's decay. A is the number in front. It's because this, initially the equation just looked like this, but B can't ever be negative. So in this case, that means that A is negative 1. Okay, so if A is missing, it's 1, unless there's a negative there, in which case it's negative 1, right? These are the ones that if they are missing, then they're 0. The only other thing before I actually show you what they look like that I want to talk about is K. This is going to be something new for us. Some of you might have heard this before. Have you heard of an asymptote before? Yay! Asymptote. Okay? An asymptote is an invisible boundary. Generally, we'll put it on the graph so that we know it's there, but we'll dash it so you can tell it's not part of the graph. But it's this boundary that keeps the graph from going past a certain point. So it'll get really, 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 really close, but it'll never actually touch or cross over. Okay. Do what? You don't necessarily need one for this, but you can use it. Some graphing calculators will graph the asymptotes, some of them will not. It just depends on which one. And you'll be able to tell the very first one you graph if your graph's asymptotes or not. So let me show you what these look like. A growth graph has a horizontal asymptote, and it starts out slow, and then it really starts going up fast. Okay? Will I say what? Asymptote? It's an invisible boundary that keeps the graph from crossing over a certain point. So here, this dashed line is my asymptote. The graph can get really, 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 really close, but it can never touch it. Okay, think about, like, for instance, if this asymptote was at 0, if this was the line y equals 0. Let's say I was cutting this number in half every time I go this way. Well, what's half of a half? A fourth. What's half of a fourth? What's half of an 8? Are you ever going to get to 0? Technically, no, because our number system is infinite. So you can get really, really close, but you'll never actually be 0. Does that make sense? Okay. All right, so here's growth above the asymptote. This is when A is positive. Remember, A being negative flips it. And all it does is flip it below the asymptote. So this is when A is negative. It's never going to touch the asymptote. No. It'll get really close. Things that grow exponentially. Bacteria. increase exponentially. Y'all have probably learned about that. As far as decay, I think y'all have probably gotten to the point where you studied half-lives of certain isotopes, maybe. Half-life. Y'all haven't learned that? Okay, so maybe like every hour it has a half-life, it decays by half every hour. You'll get to some of those things. I'm just while y'all copy this, giving you some examples of some growth and decay in real life. This is both growth. Both growth. This is when growth is less than 0 or, A is greater than 0 or less than 0. Because that A in front just flips it, this is what decay looks like. This way. This is when A is bigger than 0, and then it can flip the other way. We'll talk a lot about examples of growth and decay in real life and some problems that we can use to model that. Right now, we're just going to graph. I feel like I've bumbled around with this a little bit. I probably should have started with the graph. It's what it is. All right, let's graph. First off, before we actually graph, let me give you a couple equations. You tell me if they're growth or decay. Looking at the first one, is that growth or decay?
Decay.
Why?
Because 3 plus is less than.
This is less than 1. That tells me that it's decay. Is it going to be above the asymptote or below the asymptote? Above the asymptote. Why? This is B is less than 1. A is positive, which means it's above the asymptote. And I'll put here that's because A is bigger than 0.
Oh, wait.
No.
No, it would be below.
But it's positive. Positive or negative.
Yeah.
That's okay. That's all right. How about an asymptote? It's 0. The horizontal asymptote is y equals 0. Remember, y equals is a horizontal line, right? Okay. So without graphing, just like with the quadratics, without graphing, we know a lot about this graph, just looking at the equation itself. Look at the second one. I hear both. 3 over 2 is bigger than 1, so it is growth. Is it above the asymptote or below the asymptote? Above the asymptote. Look at the A. If the number in front is positive, then it's above the asymptote. If the number in front is negative, then it's below the asymptote. Where's the horizontal asymptote? 0 again. Last one here, growth or decay?
Growth.
What you think? Why?
Because
What are you looking at? Okay, there's an imaginary 1 in front, but that 1 is what? It's decay. Because we look at B for growth or decay, right? So here B is less than 1, which means that it is decay. Above or below? Below. Yes, negative 5. Does that make a little bit of sense? All right. Okay. All right, so let's do some graphing. Let's say I need to graph y equals 2 to the x. First thing I always want to do is to graph my horizontal asymptote. This doesn't have a lot of stuff with it, right? Where is my horizontal asymptote? 0. Now, before we graph anything else, is it growth or decay? Growth. Is it above the asymptote or below? Above. So I kind of know in general what it's going to look like, right? I know it's going to kind of do this because it's growth and it's above the asymptote. But I need some points here. So one thing I'll tell you is one easy point that you only need 2. One easy point that is always on your graph that you have to do no calculations to find is H, A plus K. Now remember, anytime I see H in these equations, that's an opposite sign for H and a same sign for K. A stays the same always. So what would an easy point on this graph be? What is H? 0. What's A? 1. B is 2. A is 1. What is K? So what's an easy point? I need one more point. Do we agree? I need to kind of know where to connect it. I know it's going to hug the asymptote this way, but I need one more point. What should I use for my second easy point? I need an X. I would use 1. Why? I'm still just going 1 to the right of that easy point that I started with. Decays will get a little bit harder to graph because I'll have some fractions and decimals. All right, so when I plug in 1, I get y equals 2 to the first, which is 2. So 1, 2. Now I can see how to connect them, right? It's going up like this, and it's coming down around and hugging the asymptote here. Of course, we cannot forget our favorite. Oh, yay! What's the domain? Yep. All real numbers, negative infinity, infinity. Range is a little bit different because I'm bounded by an asymptote. So that is restricting. Yes. Yes. 0, this time with a parenthesis. Why do I not use a bracket here? It doesn't touch. It will never, ever, ever actually be 0, so I put a parenthesis to indicate that. Does that make sense? Let's do another. This is really all there is to it. I kind of babbled a little bit at the beginning and was off to a rocky start. I do apologize. I don't know what's... You like when I babble? Thank you. I appreciate that, y'all. Let's do one that has an H and a K. Let's do one that has everything in here. So graph and state domain and range. It is decay. How do you know it's decay? That's right. 1/2 is less than 1. Above the asymptote, below the asymptote. Above. How do you know? A is positive. That's right. See, it's not hard. What do I do first? Is it -2, right? What now? Okay. So that's H. A plus K. 3 and -2, which would be 1. Does everybody see where we get those? So it's H, A plus K. It's opposite H, right? H is up here with the X. It's always in the X binomial, but it's opposite sign. Yes. Yes. We're supposed to be above because we're positive. Another easy point. 1, 0. What if I said I was going to use why might I use that instead of going right? I'm going decay. To keep from having to do fractions, I looked and said if I could make this negative, it would flip that fraction to a whole number 2 and make my life easier. It's not wrong. You can pick whatever you want. I'm just being a little extra with my graphing here because I don't like graph decimals. So I have 3. Hi.
Morning class.
All right, so 3 times 1/2 to the negative 2 plus 1 minus 2. -1/2 negative 1. Do you see why I did that negative now? Because then it's going to flip. 1/2 to the negative 1 becomes 2, which is 6 minus 2, which is 4. It's not wrong if you pick 0 or 1. You're just going to have a decimal, and it's not a bad decimal because it's a 1/2 base. Because it was what do negative exponents do?
So it's,
A lot of times when I'm talking about decay, I will move over. Now, if that had been something like 3/2, it wouldn't have worked so nicely. It only worked because it was 1/2. Just a little trick. How about the domain? Good job. How about the range? Well, tell me what y'all think about this. It's not that bad. You what? Why did I use -2? I just picked -2. Oh, that's the asymptote. What else? Y'all want to do one more? Okay. Yep. Give me an equation. Give me an exponential growth or decay equation. Y equals.
Y equals 4 times 2. 4 times 2 x plus 2 minus 4.
That's fine. So did you just give us a growth or a decay equation?
I just gave you a growth.
You just gave me a growth. How do you know it's a growth? Because greater than 1. Is your equation, or is your graph going to be above the asymptote or below the asymptote? Above.
Well, I knew it was wrong, right?
It's the A in front. The A in front's positive.
Yeah, I was looking at the
Where is your, how nice of you to join us, Joseph.
I was in the SAT class, so I was like,
it has more.
Where, though? Is it, keep going, it's what? Yeah.
0 and negative.
Is it, yeah, -4.
why do you
I don't know, man.
wait, why do you have your H?
H is opposite K, same. All right, so I need an easy point. Give it to me. -2. 0. H, A plus K, right? What X value should I choose for my next easy point? 1? -1 or 0? Let's do -1 so it doesn't get too big or too little too fast. Yeah. All right, y equals 4 times 2 to the -1 plus 2 minus 4. Plus 2, I mean, not minus 2. Golly, I was fixing to. Oh, as you do these, be very careful and make sure you go in the right order. In this case, the exponent is 1, so it's easy. But don't multiply these together first. Always do the exponent first and then multiply, because exponents come first in order of operations. 2 to the first is 2, and then don't multiply the a to the b before you raise b to the power.
But that's on your eye.
And in this case, it really doesn't matter because 2 to the first is 2.
So you would add the exponent
Yes.
before you did anything, like,
Yep.
or like flipping it, like one.
Always add the exponents, apply the exponents, then multiply. All right, 8 minus 4 is 4. Oh, wow, I went up too high. Boom, 1, 2, 3, 4. All right, so it is growth. Will's got this all stretched out. Growth, thank you, thank you. Thank you, I appreciate it. Thank you, Jazzy. You missed them singing to me and everything. Now you have to stand and sing by yourself. Yes, Alexis. H, A plus K. This is H and this is K. All right, I know I'm losing you. What about the domain? How about the range?